Okay, I will be talking about the effects of different isocyanates on polyurethanes. First, I will talk about a little history. Otto Bayer and his coworkers first made polyurethanes in 1937 and they became commercially available in 1952. Early production of polyurethanes was focused on fibers and flexible foams. In 1954, toluene diisocyanate, also known as TDI, and polyester polyols were used to produce flexible polyurethane foams. Polyurethanes are formed by reacting a polyol, which is an alcohol with more than two hydroxyl groups, and a diisocyanate or a polymeric isocyanate. The figure here shows the reaction between a polyol and a diisocyanate to form a polyurethane. There are many different forms of polyurethanes, and they can be in the form of foams, elastomers, paints, coatings, adhesives, and elastomeric fibers. The most common form of polyurethanes is in foams, and these account for about 30% of the North American polyurethane market. The four types of polyurethane foams are flexible, semi-rigid, rigid, and integral. Flexible polyurethane foams are used in applications that include bedding, furniture, automotive interiors, and carpet underlay and packaging. These foams are light, durable, supportive, and comfortable and can be created in almost any shape and firmness. Rigid polyurethane foams are most effective in insulation materials that are used in roof and wall insulation, insulated windows, doors, and air barrier sealants. Isocyanates are compounds that contain the isocyanate group and they are highly reactive with low molecular weights. Isocyanates are powerful irritants to the eyes and skin and can cause breathing problems if they are not handled properly. The compounds that make up isocyanates can be classified as possible human carcinogens, and continuous exposure to these can lead to asthma and other lung problems. Because of the poisonous nature of isocyanates, proper handling, clothing, and ventilation systems in the workplace are of the utmost importance. Because the polyurethane industry has tremendously expanded, so has the number of workers and consumers, and with these numbers rising, the risk of isocyanate exposure has also risen. The two most commonly used isocyanates for making polyurethane foams are toluene diisocyanate, or TDI, and methylene diphenyl isocyanate, or MDI. Toluene diisocyanate is a key raw material used in the production of flexible polyurethane foams, and the most commonly used TDI is an 80-20 mixture of toluene 2,4-diisocyanate and toluene 2,6-diisocyanate, and the figure here shows the structures of these two. Toluene diisocyanate is known for having a fast gelation rate in polyurethane reactions, and as mentioned above, overexposure to TDI can be a health risk because of its poisonous nature, and the possible routes of exposure are through inhalation, eye contact, skin contact, and ingestion. TDI is used because it helps produce lighter automobile parts, which saves weight and leads to improvements in fuel efficiency, which therefore conserves energy. The other commonly used isocyanate for the production of polyurethane foams is methylene diphenyl diisocyanate, or MDI. The figure here shows the structure of MDI. MDI is used as a replacement for TDI, but it does not have a fast gelation rate like TDI. MDI is more commonly used in rigid polyurethane foam production. As mentioned before, rigid foams are used in insulation materials, and insulation made with MDI helps consumers save on heating and cooling costs and therefore conserves energy. MDI is also used in some coating, adhesives, sealants, and elastomers found in products like paint, glue, and weather resistance materials. MDI is also used to make footwear and sports products and a few specialty flexible foams, and can also be used as a wood binder. Just like TDI, MDI is poisonous and can lead to various health issues such as breathing problems and skin irritations. The isocyanate index, also abbreviated I, refers to the amount of isocyanate used in the production of polyurethane foams. The isocyanate index is a ratio of the amount of isocyanate groups divided by the number of hydroxyl groups, or NCO divided by OH. The ideal isocyanate index is 1. For thermoset polyurethanes, the isocyanate index is greater than 1, and for thermoplastic polyurethanes, the isocyanate index is less than 1. The isocyanate index has an effect on many properties, some of which include tensile and thermal. An increase in the isocyanate index of a rigid polyurethane foam causes the density of the polyurethane foam, as well as the compression strength, to decrease. and also causes the glass transition temperature, dimensional stability, and thermal insulation to increase. There have been many studies done that in terms of the isocyanate index. The results from one study showed that when the isocyanate index was 2, the polyurethanes had a very high tensile strength compared to when the isocyanate index was 1.5, which showed a decrease in tensile strength. In the same study, the glass transition temperatures were shown for castor oil polyurethanes. When the isocyanate index was 1.5, the glass transition temperature was 60.6 degrees Celsius, and when the isocyanate index was 2, the glass transition temperature raised to 93.4 degrees Celsius. And to summarize up everything I've just said, the production of polyurethane requires a polyol and an isocyanate, and the most common use of polyurethanes in North America is in the polyurethane foam industry. There are 4 common types of polyurethane foams, and these are flexible, semi-rigid, rigid, and integral, and each of these have different applications. The isocyanates used to create the foams are poisonous and can be very dangerous if they are not stored and handled correctly. The 2 most commonly used isocyanates in making polyurethane foams are toluene diisocyanate and methylene diphenyl diisocyanate, and change in the type of isocyanate and even the concentration of the diisocyanate has effects on the polyurethane that is formed.